In our previous video, we looked at how to describe qualitative variables. Now let's look at how we would describe quantitative variables. So if we're treating ordinal as quantitative, we can use these approaches, some of these, and then otherwise we're using it for interval and ratio data. So when we're describing quantitative variables, we can do a numerical summary, so a 5-number survey or summary. We can do graphical representations, histograms, dot plots, box plots, stem and leaf. There are others we'll look at in later videos. And we can summarize the information with mean, median, and mode. And we can also use a number of measures of dispersion, range, interquartile range, standard deviation, variance, and the coefficient of variation. So let's take a look at some of these. So we'll start with a histogram. A histogram is a graph of quantitative data where the values are marked on the horizontal axes and the frequencies are on the vertical axes. Now, if we're dealing with data like weight, then you may not have in your sample, let's say 100 people, you may not have multiple people who are a weight of 150. And so when we create histograms, what we do is we bin the data. We take groups, chunks of the data, and in order to create that kind of bar graph, you'll note here the difference between a bar graph and a histogram is that the histogram, the bars touch each other, whereas in a bar graph there was separation. And that's to denote the fact that it's actually a range of numbers within each of those bars. In this particular example that you're seeing here on the screen, they're looking at hand span, how far your hand stretches. And if we measure that in centimeters, one person might be 18.5, the next one might be 18.6, the next one 18.65, right? So if we created a distribution that had each particular number, it'd be really hard to see what's going on. So instead what we have here is we create these bins, and here you can see that the bins go, what do we have here? We have kind of like 16 to 17, 17 to 18, 18 to 19. So they might be bins in terms of 2 centimeters. Okay. Now when we're building histograms in Excel, you can build them by hand and specify the bins, or you can use the automated approach where it decides what the appropriate bins are. Now, when it comes to histograms, what you want is you want about 6 to 15 different bins, just because you want to see the distribution. We want to see that general, as we look at this, we want to look at where is the mode. The mode is the most common. So we need to have enough bins that we can see, here's more extreme value, here's the most common value, but you can see this distribution. If you only have 2 bins, if you lumped everything together, then you'd have a very wide bin and you really wouldn't know whether people's hand spans are 20 or 24. And you'd really just kind of have 2, right? More than 20, less than 20. It'd be really hard to see that there were any outliers or extreme values, and also kind of what is the central tendency and the variability. So we want to have more bins, but you don't want to have too many bins. If you have teeny tiny bins and lots of them, so let's say we did every 1/10 of a centimeter was its own bar on this graph, then it would just be uniform distribution and be flat. You have one person in each category, and you really couldn't see any information on what was happening in terms of that congregation of data in a central area. So that's why when you're creating the bins, 6 to 15 bins is kind of what you want, so that you can see that variability as you're looking at it and that central tendency. As I said before, histograms have bars that touch, bar graphs don't, and that's to indicate that the data is continuous, that it could be numbers in between, whereas a bar graph, because it's categories, they are separate and distinct. Okay. So let's look at how we would create a histogram in Excel. So let's just open up Excel here. So here we have our data. We have our height and our hand span. And so we could then create a histogram on, for example, hand span. Okay, so we could highlight this information here in our data. And on the Insert tab, which you can't see, so I'm going to move that down a bit here. Again, I'm doing this in the Mac version. Microsoft 365 Excel, but it is the same on the Windows machine. Insert, and then what you want to do is you see how this one has the bars that are touching. So we want to go with a histogram. This is the default histogram where it is going to decide the number of bins for you. So it's going to decide the cutoffs. The downside to that is the cutoffs might be kind of random. You can see here the cutoffs. This one goes from 16 to 17.2, 17.2 to 18.4. So you can see the ranges are kind of wonky, maybe not quite what you wanted. Alternatively, you can create a histogram where you define the bins. To do that, you are going to go into data and you're going to need your analyze tools. So you're going to need this analyze tool pack to be installed if you're going to use the old school histogram method in Excel. So you'll need that. And then if you do that, oh my goodness, my nose is just, okay. Then we would highlight the data just like we did before. And we go to data analysis here. And then you would choose histogram. See if it's still in here. Okay. Now, you need an input range. You also need a bin range. So you would need to specify your bins. So I'm going to just change this out here. So we would specify our bins. So I'm going to do 16, 18, 20, 22, 24. Okay, so I'm going to make a bins list. So I'm going to go back to data analysis we're under data ribbon and we're data analysis and histogram. And then my input range is going to be my data. And my bin range is going to be these list I made here. Okay. Do that. And then give me a chart output. Okay. So here it doesn't look like a histogram, right? Because it has the spaces in between. That's because Excel, you had to have this a special virtual basic add-on to create the histograms because it wasn't built into their system. Now they have created an actual histogram. That's the one we saw before. The difference here is that this is going to show you, this is that there's one that is 16 or less, one that here that is between 16 and 18, 18 and 20, 20, 22, 22 to 24, and then the more than 24 gets put here. And so we can see then the most common is that 20 to 22. So we just compared this one here to the built-in one, which I deleted. That wasn't good. Insert. So you can see again that 20 to 22 is the most popular. This one has the actual correct look of a histogram. The only downside is that the bins it randomly decides where to do the cuts. In terms of the actual, like, what does this bin mean? The new histogram here is easier to read as to what is included, whereas the other one, because it was using the old bar graph method, is not as easy to read. It does have this more category, which is nice, but in terms of what is the width of the bins, it's harder to determine with the old version. To help you interpret the Excel, let's just go back to this one here. So notice there's hard brackets on these numbers and soft brackets. So a hard bracket means including, and a soft bracket means not including. So what this tells you here is this includes 16 all the way and including 17.2. This next one does not include 17.2. It's a soft bracket, so it's above 17.2, but it does include 18.4. That's what the hard bracket means. So a soft bracket is not included. A hard bracket is inclusive in that range. So this is a bit easier to read than this one here in terms of what is actually in that particular range for that histogram. When we are looking at the histogram, just go back to my slides here. We talked about what a histogram is, but the benefits of a histogram, right, is that we can easily see at a glance the variability. We can see the outliers or extremes. We get an idea of the shape of the data set. The downsides to a histogram is that it's difficult to get information out of small samples because it's all going to look like a uniform distribution. And then it's going to be very much impacted by our choice in the number of bars. So when you're doing bars, 6 to 15 is the number of bars that you should have. Number of intervals. If you do the Excel new histogram, it will do that piece for you, but the downside is that it random breaks at weird places. All right, when you're looking at the shape of your histogram, is it symmetric? Does it have that bell-shaped curve? So the tails on the two ends are equal in size. So you see that's here a typical normal distribution. Is it skewed? So if you have a couple of extreme high numbers, you're going to have a positive or a right skew, a big bump on the left and a big tail on the right. So when we talk about right and left skewed, we're talking about where is the tail. We're talking about if it's a positive skew, then there are big numbers that are pulling part of it towards the right here. If it is a negative skew, then there's some low numbers that are pulling it to the left. So we're looking at skewness. We're also looking at, is it multimodal? So when we talk about the mode, the most common response in a symmetric distribution, that's right here, that's the one hump. If you have a multimodal distribution, perhaps it is bimodal, so two bumps, then you have two modes, two most common. There's one there, there's another commonality there, which might indicate that there is two groups here that are being put together. So for example, if we go back to the data about the hand span, it is quite possible that those who are male have a different hand span than those who are female. And so if this multimodal would tell us that we have two distinct groups within the data set. And so perhaps we should separate them out and look at the distribution related to male and the distribution related to female. So if you have a multimodal distribution, it tells you maybe I should look further at the information in the data. If we're doing this from a quality management perspective, perhaps we are looking at how long it takes to fulfill orders. If you have, the majority of orders take this amount of time, but then there's also this grouping here that take this amount of time, maybe there's something else to the data. Maybe these are two different shifts. Maybe these are two different locations that have been put together into one data set when really there's something unique about those different shifts or different locations. Okay, so we're looking at that distribution as we're looking at our histogram. We also need to look for outliers. Outliers are data points that are not consistent with the rest of the data. Now, it's quite possible these are completely legitimate data points. There's just something unique or different about them. Perhaps it is also a transcription error. So we went to type in the age of the participants, and instead of typing in 20, we typed in 2. Okay, and so it's going to flag for us that there is an error in the data. If we can verify that it should be something else, here's our chance to correct it. Okay, so we look at, is it possibly an error or is it something unique? Maybe that individual belongs to a different group than the rest. Maybe they need to be separated out because they have different characteristics. There's something different about them, and we really should be observing and identifying relationships with the groups separately.